Om Shri Sai Ram. Let us begin this session with a prayer. Om Sai Ishwaraya Vidmahe Satya Devaya Dhimahi Tanna Sarva Prachodayat. Om Shanti Shanti Shanti. Okay, let us quickly recap where we were. So we were looking at this new software stack for big data. We have understood what is big data, why do we need big data algorithms, and where is this big data area applicable, and we came up finally with the software stack solution saying that if we have to work on big data algorithms, we need two very important pieces of software. One is that we would need distributed storage, and for distributed storage we are choosing a distributed file system, and specifically we are looking at HDFS. Remember, HDFS stands for Hadoop Distributed File System. There are many other distributed file systems, but in our course we are trying to look at HDFS, and we also have another course called Hadoop Programming, where HDFS will be dealt in much detail. Apart from distributed storage, we also understood that we need a distributed computing platform, and what we are going to look at today is a very famous distributed computing platform called MapReduce. Again, remember that MapReduce is not a new idea. In fact, I remember working in the HPC platform with a message passing interface called as MPI, and I remember using a lot of reduce calls there, which means that it is quite a known solution. It is not like something out of the ordinary. But why is it that we are not able to pick up existing solutions and trying to adapt them to this for distributed data parallelism model? Somehow what has happened is these kinds of environments where like HPC kind of environments have somehow stuck more to scientific community, and there has been a slight gap in bringing into the data processing community. Also, I think people have probably felt that this needs some special skills, or it may need special hardware. But in any case, what has happened is along with the birth of a commodity cluster, remember this was our hardware solution that we are looking at, commodity cluster. Along with that, the software stack that's typically accompanying for data processing environment nowadays is, for storage we are going to use HDFS, and for computing we are going to look at MapReduce. Now MapReduce again is a distributed computing platform. It's an idea, it's a framework, and many implementations of it are available. In fact, Google has its own implementation of MapReduce, which internally it's called again as MapReduce only. Its implementation is also called MapReduce. Now Apache has its implementation, which we are going to talk about as Hadoop. Okay, and there are many more such implementations that are available. Okay, one more maybe. In fact, Apache has one more that they call for using Spark. This is a very famous MapReduce platform again. Now, what is important here is to understand that when we talk about Apache Hadoop, when we try to download Apache Hadoop from its website, you will find that we get the distributed file system, plus you also get the distributed computing platform together as a package, and that has become an advantage. So and of course this is open source and it's free to be downloaded, and we install it. And I remember that we had set up a simple cluster, 8 node cluster for your senior batch, and we were able to quite comfortably run a lot of large data processing algorithms on that platform. So in summary, if we want to just quickly recap what we have discussed till now, is just one word. This one word, very important word that we have learned, which is called as Hadoop. And what is Hadoop? Hadoop is a software package that's available on the Apache website where we can go and download, and it brings along with it both HDFS and the distributed computing platform. Now the distributed computing platform itself is also called as Hadoop. Okay, so you have to understand the naming, the meaning of it based on the context with which we are speaking. So what we are going to look at is the MapReduce implementation of Hadoop. Okay, now that we have an idea of what we are going to discuss, we are going to discuss the Hadoop MapReduce distributed computing platform. Let me put the context in place. So I want to next talk and discuss about these two words that we have heard. One word that we have often heard is library, another one is a framework. So let us try to get the distinction between the differences between these two, and will help us understand Hadoop. There will be a better picture. Okay, let's understand first what's a library. So a library is like a set of functions that are already compiled and given to us, let's say in binary, and based on what we want, we could choose any function from that library and we could invoke that, right? So that means that the user is in control. When I say the user is in control, the user writes his code and can pick up, he can choose, he can pick or choose functions from the library. And generally library is quite a lightweight model. Let's take an example. What kind of example? Okay, let's say that you are working on C code, and if you are asked to use mathematical functions, say you want to use the sine function, let's say, then you can actually choose to use that by doing a hash include of math.h. You can do a hash include of math.h. Apart from that, when you compile and link, possibly you may say whatever files, and finally you may include this called as -lm. When you do this, what will happen is you will link to the libmath library of the C library. It will be a libmath package of the C library, and your code will start working. The sine will get its implementation from the libmath library. Okay, this is the typical process. Now let's look at a framework. So how I'm going to kind of distinguish this from library, probably I'm going to call this as an independent software infrastructure. Now look at a library. A library is basically a dependent piece of software. Now why am I saying it's dependent piece of software? Because by itself a library is not something that can be executed. A library is something that helps others execute their code, which means that the user can pick up functions, add them to his code, and we can execute it. Now what are we talking about in a framework? Framework is not a library. I mean, it could consist of libraries, but the idea of a framework is that it's already an independent software infrastructure. Means that whether a user has his code or not, there is something already built in and available to run. And what control does a user have? User can maybe add or modify certain units in the framework. So user doesn't have the choice to write his own piece of code and try to call or adapt certain functions from the framework. Now that's not possible. He was doing this only with the library, but now what he can maximum do is he can go and write a plugin into a framework whichever the framework has exposed, which means who is in control? The framework is in control. It's not the user who is in control, but it's the framework that's in control. But user has a choice. User has a little power here where he is able to go and plug in into certain functions and say that, here is my implementation of this function. Please use this implementation instead of the default implementation. Right? So that is the amount of control that the user has got with respect to a framework. So let's take an example. So the best examples that we can always look at are graphic frameworks. For example, let's say we talk about the Swing framework in Java. We talk about Swing framework in Java. I'm sure you might have programmed on Swing, program using Swing in Java. You will find that there are specific methods that you can go and handle. Let me try and remember some methods. Okay, one example that I remember is we used to use this called as paint component method. A paint component method. Now what Swing says is that whenever a refresh of the screen or when components are going to be painted, this method will be called by the Swing framework. It is optimized in Swing, and Swing framework will automatically call it whenever the screen has to be refreshed. And it tells the user that if you want to paint something on the screen, you could implement this specific method in your own way. And that would be the control that generally we use in order to perform some graphics animations, or you want an item to move on the screen, then we could use the paint component and we could write our own code there. But remember, we were not in control of calling the paint component itself. The call of that originates only from the Swing framework and not from the user. Okay, I'm hoping that we have this distinction now clear between what's a library and what is a framework. Okay, so why did we get into this discussion? The reason is that we are going to look at MapReduce, which is not a library, but it's a framework, which means somebody else is in control and you are given certain pieces where you can choose to modify, or maybe you can add your methods, etc. Nothing beyond that. Just as an aside, it's interesting thought that occurred. I wanted to ask you, many of us have our own will, so let me put this as my will, and we have God's will. Okay, let me ask this question. We do many things out of our own choice, and unless my will is there, I'm not going to act. On the other hand, we also have God's will, and generally it is said that unless there is God's will, even a blade of grass can't move. Okay, let me give you an example. Okay, try to take your right hand, take it up and down, take it up and down 2-3 times. Now understand that you are able to do this because you have your own will of doing it. Since you willed it, it happened. Okay, now where is God's will here? Let's just assume for a moment, sorry, pardon me for this wrong example, but let's say that your hand gets fractured. The same right hand gets fractured. Let's say you are on a sling or you're on a cast. Now, can you still will that you can move your hand? Yeah, you have your will to move your hand, but why are you not able to move it? The problem is that his will is not there. Okay, now that you understand the difference between my will versus God's will, my question is going to be, can you classify these two under library and framework? Okay, you could think about it, but let me put what comes to me. I'm going to say that my will is my will is, I'm going to get control like a framework, and God's will has control like a library. Now, how do I say this? Let's talk about destiny. There are many things that are destined to happen in our life. Okay, so we are undergoing a pandemic here. None of us would have probably even expected such a thing, but then we have to undergo this because it is this. Okay, can we change the scenario? I guess not very easily, but I think we are attempting, and therefore, this is his choice. He wants to present something, he will do it. He has got all the control. So he picks up one simple function called a pandemic and invokes that function, and the pandemic is released. Okay, now what is my will here? There are many things out of my control now. I can't be stepping out of home. Even if I step out, I have to wear a mask. I have to ensure that I am not a carrier of the disease, neither am I getting affected by the disease. And therefore, all that I have is those choices. So those, are like those framework methods like paint component, etc., where you can decide, you can choose whether you will wear a mask or not. It's up to us. So if you want us, if we want ourselves to be, infected, we could easily do so. But if you want our safety of health, I think we will make a wise choice. And therefore, my will is only like a framework. In this complete destiny that we have to undergo, I think we have certain areas of choice where God lets us choose. And it's very important that we make the right choices there. Okay, I'm going to stop that there, and let's continue our discussion on MapReduce. So what is it that we have understood? That we have understood that MapReduce is a framework. So Hadoop MapReduce is one implementation of the MapReduce framework idea, and this specific implementation gives us two choices. There are many more, there are a few more choices, but the most important choices that it gives to the user are what is called as map and reduce. So there is an availability of a function where the user can go and plug in and say, here is my map function and here is my reduce function. Now the rest of the implementation or the rest of the flow of control is not within the user's control. It is under the control of the MapReduce framework. Okay, first let me show you the node picture. I'm sure we remember the hardware platform, how it looks like. It was organized as nodes and racks, etc. But here we are talking about a logical diagram. In the cluster, we will find that we have to mark one of the nodes as a master node. Of course, there are configurations where the node can act as a master as well as a worker and all that. But typically, when anybody sets up a cluster, they separate the master node away from the workers. Now, we use the master node. That means that multiple users can log in multiple users can log in into the master node and submit their job or submit your program. And when you try to run your program from the master node, what happens is that it distributes the work onto the worker nodes. So what is the distinction, distinguishing factor between master node and worker node is that the master node is somebody who collects all the jobs, maintains all the jobs, finds the status of the jobs, etc. Most importantly, it distributes the job onto the worker nodes. Here is one node who would understand the entire complete picture of the distributed file system, of the distributed computing framework. All this is known to the master node. What is the job of a worker? Collect the task, run the task, and do accordingly as the master says. Maybe produce the output, and we will see whether he is going to give the output back or he is going to leave it here only. That we will see later. But his work is pretty simple. He is actually the brain behind the entire MapReduce program, where these are the people who are running behind the scene on the actual tasks. But here is the kind of the interface that we have to the entire platform. You use the master node, we log in and we submit here. There is no necessity that we have to log in directly to the worker nodes. None of us, it's not required to actually log into the worker nodes. I'm not saying that you cannot log in. We can log in and then look at it. But if we want to use the distributed system or distributed computing platform in the right way, we would get into the master node, submit our jobs and leave the responsibility to the master node. Okay. Now that we have the logical hardware picture of how this distributed computing platform is going to work, let us actually start looking at this diagram at a task level. To understand it at a task level, obviously we need to first understand what is a map, and what is a reduce. And when we are going to say what is map, what is reduce, we are also going to equivalently use the term what is a map task and what is a reduce task. Okay. In order to explain what is a map task, let me pick up the picture of the HDFS Hadoop distributed file system, where let's assume either we could say they are set of documents, or as we understood earlier, let's say there is one large document that has got split up into multiple chunks. Remember the chunk size in HDFS? If not, please go and refer. Of course, it is configurable, but there are some typical sizes that we should always remember. Okay, so what I have done is I have distributed the chunks to different nodes here. Okay, so here is one more fact we have to remember. When we set up the cluster with Hadoop, as I mentioned earlier, you would set up HDFS and also the Hadoop MapReduce computing platform. They work hand in hand together. So here I am discussing map task, which is part of the Hadoop computing platform, computing framework. Whereas in order to understand this, now I am starting to discuss regarding file chunks, etc., which is talking about HDFS. Okay, so let's assume that we have a very large document that has got split up into multiple chunks, and the chunks are stored in different nodes of the cluster. Yes, we did speak about replication, etc., but we are not worried about those replica factors now. We are starting to look at the file chunks that are available in different worker nodes. So map task asks you this question. It asks, what is the processing that you want to do at each chunk? Map task says, what is the processing that you would want to do with respect to each chunk? You could assume that the document has got, let's say, a set of words, and you may want to count the number of words that are totally present. Okay, that could be one example. Or you may say, let's find the occurrences of each of the words and find out how many different times or how many number of times each word occurs. That could be another application. So what are we discussing? We are discussing, therefore, what is the processing that you want to do at each chunk, and please represent the output of this processing. So perform the processing in your code and produce the output of this processing as a key value pair. Okay, what is a key value? Two simple units, two simple concepts. I mean, there is nothing that is very rigid about key and value. We could have a string and an integer. You could have an integer and a float. I mean, you could have any typical data types as both keys or values. But the point is that when we say key and value, we understand that with respect to this key, I have a specific value. Given a key, I can always identify what is my value. But please don't imagine this to be something in the hash map. Now, what happens in a hash map is, given a specific key, there is a single value that you can go and obtain. Whereas if you take another key, then you will be probably taking another value. Now, this is slightly different understanding that you have to take from the differently from the hash map. So you could have any number of common keys, and they could have common values or they may not have common values. So let me give you an example. Let's say this is one key value pair. I can have another key value pair like this. I can have another like this, and I could have this itself again, right? So let's not restrict ourselves to the understanding what we get in the hash map. But key value pair means a pair of two units. They could be strings, or they could be integers, they could be any data type, but they're just a pair. Okay, so let's quickly understand again, what does map say? Map task asks the question, what is the processing that you want to perform at each chunk, and produce its output as a key value pair. Let's move to reduce task. Reduce task asks the question, what processing do you want to perform? Processing on the list of values for a key. Very important statement. Remember, the processing here is at each chunk. Here the processing is not on chunk. The word chunk has disappeared, and it says, what processing do you want to perform on the list of values? It's not even saying on a value, few values. No, it's saying on the list of values for a key, for a specific key. Okay, and let me put the format down here. Since I said that we could have the same key with different values, what we are talking about here is, we may get for this key, what are the values we got there? 3, 4, 3, etc. Similarly for 6, I think we had just 3 here, so I mean that would just be a single element in that list. So what has happened is, what reduce defines or asks us to define is, what processing do you want to perform on a key with its list of values. So we would have to use this list of values, and we have to define our processing. Like that, you will have to do it for every single key. I mean, I will tell you how it happens for every single key. What the user needs to define is, what is the processing that's required on this list of values. So what we will do next is to pick up an example, and we will try to understand what is map and what is reduce for this example. Let's assume that we have a list of few animal names, a few insects, rodents, all these are mixed together and given to us. That file or document is extremely large, and when we store it in HDFS, it gets distributed as different chunks. And here is an example of the animal names or rodents or insects that are present in each of the chunks. So in worker 1 I have these, in worker 2 I have these, for 3 and 4 these, etc. Let's say that we want to process this to find the most frequent species. Okay, we'll have to figure out which is the most frequent species. So we have to, let's say, process this and find if is it going to be cat, or is it elephant, or is beetle or ant, or what is this, which is the most frequent species. If we want to write a traditional algorithm for it, what we would do is we would pick up the entire file, and as we go across each word, we may have to store that word whenever it's a new word. If it's a word that we have already come across, then we will add just one more count to it, and at the end of processing this file, we will have to look at all the words and their occurrences, find out which is the maximum one out of the occurrences, and produce that as the output, reporting it to be the most frequent species. But here we are not going to write a traditional algorithm, we are going to write a MapReduce application. So we want to ask what should we do in map and what do we do in reduce. Okay, this is what we're going to do. Remember that map processing is on every chunk. Now I have written a few names of animals and rodents here, but that could be part of multiple chunks, and a map task could work on one or more chunks. We will describe more about how many map tasks to how many chunks, etc. later, but for now assume that a map task is looking at the chunks that are available on these workers. So I have a map task on worker 1, I have another map task on worker 2, so on 3 and 4. Okay, what we want the map task to do is, if you find a word, please write that word as the key and put 1 as its value. This is the code that we are writing in the map task. So let's take an example and try and do. On worker 1, what will happen is, it sees the word cat, then the output of the map task will become cat, 1. It sees the word dog, the output is going to be dog, 1. The next word is elephant, then it outputs elephant, 1, and finally for mouse it will output mouse, 1. And I am sure you can understand what happens here as well, because it's the same map the same map code, of course different tasks on each, and all of them will be operating simultaneously. As this map task is running on worker 1, obviously map task 2 is running on worker 2, and simultaneously something is happening here and something is happening on worker 4 as well. Okay, now what did reduce say? Reduce says I am not going to work on chunks, but I am going to work on the list of values given a specific key. And what we defined here reduce as is, we say if I get a list of values, I am going to sum them up. That's it. That is my reduce code that we are going to write. So let us see what happens. Let's talk about cat. So cat, 1 will appear from here once, from worker 1, then from here once, and that's it. And therefore I will have the key is cat 1, 1. That will be the list of values. Remember that we were talking about list of values for reduce. The next one is, let's talk about dog. Okay, dog, there is 1 here, here 2, and that's it. So you will have here 1 comma 1. I think I can pick up just one more example. I'm hoping that you have understood this. So let's pick up this ant is here once, here second and third. So ant would be 1 1 1. Just as an odd example, if you want to see if something is just coming once, then maybe if you take lion, then the list of values will just be 1. Now what does reduce say? The key and the list of values should get reduced to key and a number. That number is determined by the sum, because I have defined this to be the sum. Therefore this would become cat comma 2, then this would become dog comma 2, this would become ant comma 3, and this will become lion comma 1. Great. So with map and reduce, we were able to bring out the words and marking that this is just one of the occurrences. The one helped us, and when it came here, we somehow saw that all these individual key and values have become key and value list here, and with our definition of the reduce, they got further reduced to cat comma a specific number, key comma a specific number, etc. Of course, you know, the task is still not over, our goal is still not over. Maybe our answer is sitting here, but we have not finished that in our program. The most important question that we need to ask is, how did the key value pairs become key and value list pairs? They have become from key value pairs, they have become key and value list pairs. This is done by the framework. Which framework? We are talking about the Hadoop framework. Now I am hoping you are able to appreciate why we discuss framework in the first place. You see that we are able to control the map part, we are able to control the reduce part, but the remaining is all running as part of the Hadoop framework. So the moment we give this, the framework at the end of the map, after all these tasks are getting completed, it would, so this statement that I am making is a little qualified statement. I may change it later, but for now to understand, let's keep it simple. So the framework, after all the map tasks are completed, will pick up these key value pairs and it groups them. This is called the shuffle phase. In MapReduce programming in Hadoop, this term, it's a technical term being used called the shuffle phase. But we need not worry about this term. More important is what is the activity that it performs. It is grouping by key. It is grouping by key. So it finds the key and values. Maybe it could sort them, or it could use some other data structure where even sorting could get avoided, and it picks up if cat has occurred, cat comma 1 and cat comma 1 has occurred multiple times, then it says, let me put this here in a list saying 1 comma 1. Similarly for ant, it is going to put it thrice. So this combining the key value or grouping the key values into key and list of values is done by the Hadoop framework. Okay, so we have not completed the problem, we have not solved the problem, but the problem is taken as an example to only understand this computing framework. Of course, we are going to do many examples, and at that time we will worry more about completing this problem, but for now let's focus on understanding this platform clearly. So what does map do? Given a chunk, it will tell us what is the processing that we need to do on the chunk. What does reduce do? Given key and list of values, it asks how do you want to reduce that list of values into a specific unit. That's it. The rest of the job is taken care by the framework. And now we will look at a little more deeply into how this framework is operating in order to complete, or in order to bring this entire picture of working. Okay, so we were initially, if you see the previous pages, we were talking about what is called as a master node, and at that point when we try to launch a task, we can configure certain things, okay, for a job. So there's one thing that we can configure is the number of map tasks and obviously the number of reduce tasks. The typical number for a map task is, I'm only saying a typical number, you can guess it, is going to be same as number of chunks. Why is it so? Because you want one task for every single chunk, so that we are able to complete the entire task as quickly as possible. There can be further questions here itself. Is it possible that one map task can operate on multiple chunks? The answer is, so let me write this down. Can I have one map task operating on multiple chunks? Answer is yes, we can. If we decide that we do not want a task for every single chunk, it will overload a worker node, then we can decide and say that we just want one map task for multiple chunks. So that map task will take care of all the chunks on that specific worker node. Okay. Now other way, can I have multiple map tasks for one chunk? It is a meaningless question. We don't want a chunk to be further divided. That is why initially we divided the file itself into chunks. If we are further wanting to divide, then let us define the chunk size itself in such a way that the minimum configuration we can look at is one map task to a chunk. So a map task can operate on multiple chunks, but the other way, nobody uses multiple map tasks to operate on a single chunk. Now, the moment we say that a map task is associated to a chunk or a multiple chunks, it is obvious where the map tasks are going to get launched. Where should they get launched? They will get launched on the nodes where the file chunks are present. Now that is a very, very important fact. Map tasks are launched on worker nodes that contain the chunks. Now I'm going to ask a question at this point. Why is it that they can't be launched on some other worker nodes where the chunks are not present? Please try to pause the video here and try to answer this for yourself. The answer to this question comes from this principle that we learned earlier. If you remember, we said move program to data. We are going to take the map task and launch it only on those worker nodes where we have got data. And so what is the advantage? We are not moving data. Remember, in big data analytics, it is the data that is large, and therefore moving data is a huge bottleneck which we do not want to do, and therefore we are moving program to data. See how the principle that we learned has come down to the implementation today. Okay, so I'm hoping that you have an idea of what are map tasks, where are they getting launched, how many are getting launched. Okay, now let's talk about reduced tasks. Again, as we have learned earlier, reduced tasks are independent of chunks. They are not dependent on the number of chunks. Whereas map tasks, at least to an extent, they are dependent on the number of chunks. If you say is 1:1, you could decide the number of reduced tasks. For example, let's say that I decide that I would want 3 reduced tasks. Okay. Now it's up to the system, it's up to the framework to decide where to launch these 3. Where to launch these 3. It could be on worker nodes that have data, or it could be on worker nodes that may not have data. Oh, okay, that is interesting. Why is it that I'm saying that they may be on worker nodes where data is available or not available? The reason is, what if we launch the reduced task on a node that is already running map tasks? Now, it is possible that that specific node could get overloaded. Okay. Second, if a reduce has to work, it may need data from different worker nodes, and that is the topic that I would like to dwell on probably in the next session. But for now, let me quickly summarize this session. What we learnt in this session: we have looked at distributed computing platform, which we called as the Hadoop distributed computing platform, and famously called as the Hadoop MapReduce distributed computing platform. Then we saw what is a framework. Then we described the hardware structure logical diagram, the hardware logical diagram for MapReduce, and we also saw what is map, how many tasks, and what is reduce and how many tasks. Right? I'm hoping that we have a brief idea about MapReduce computing platform, and the topic this topic is going to continue into our next session, and with that we will get a much better idea of MapReduce. Let us end this session with a prayer. Om Shanti Shanti Shanti.